Alright, good evening everybody. This is William Pan, and this is my presentation for the final project ECE9014 Data Management and Application class. The topic I've chosen is a database system for ebook. And the reason I'm using Lockton Kobo as a prototype to model from is that first, Lockton Kobo is a Canadian ebook company headquartered in Toronto, Ontario, and it has the largest market share in Canada as well as a significant market share in Japan. So that's the reason I think it's a good example to study from how they work with it. Also, a main reason, a main problem I'm interested in choosing this topic, specifically choosing Lockton Kobo as a prototype, is that I'm interested in the way they manage the region, like no matter manage books by region as well as user by region. Because different from Amazon, for example, Amazon Kindle has different domains for different regions, like Amazon CA, Amazon.com, Amazon.co.jp, where they could totally use different databases for different regions. But for Lockton Kobo, however, like this screenshot right here, they only have kobo.com. We're only using past parameters like JPJA, for example, that stands for Japanese, to indicate the service region during a request. So, from my opinion, it's really likely they have a centralized database to manage the service across region. So I'm really interested in to validate my guesses. For example, like having entities like book and region as user, a relationship between them is gonna help solve the problem. Quick mention of the tech stacks that are involved in this project. That includes MariaDB, which is a fork of MySQL, and by default the default option for Linux distribution like the operating system I'm using, as well as using Python and certain libraries for the web scraping, because I believe using the real data web scrape from kobo.com is gonna better help us validate how the database we got is working. So starting with database design, so all this final ER diagram here shows the entities as well as relationship I propose that could at least fulfill the minimum functionalities of the platform we're proposing for. Starting with the books, we have defined relationship between book and publisher, author, genre, as well as region. So we can filter the books using those entities. Books by specific publisher, book by specific author, as well as what are the books under one genre or specific like two genre, as well as most importantly, books that are under certain regions, as well as user and region relationship is many to one, because we have to assume that a user could only be from a certain one region, and of course he or she cannot buy a book from another region. Order turner relationship includes review as well as transaction, which is order, and should be okay for the minimum requirement for a platform. So after the database has been designed, we could, using this ER diagram for reference, to create a database in MariaDB, for example here. A quick mention that in order to do the to connect to visualizers, like no matter it's MySQL Benchwork or dbeaver, we need to connect it, but MariaDB by default doesn't allow connection from super user. No, does not allow from root user, but we create it using a super user, which the privilege or is originally or belong to the root user. So that involves granting all the privileges to some non-root user, then connect to the non-root user. And then for the creation database, for each entity, we create the table for them using data definition language, using operators like create. And the only thing that really needs to be noted here is the definition of the relationships. For a many-to-one relationship, a foreign key constraint is enough to do the work. We keep the foreign key on the many side of the relationship. For example, book and region. Book is a many side, so we could have the region ID as a foreign key stored as a column in the book. However, for a many-to-many relationship, this is not enough, so we need an additional table for this. For example, something like to call a hash table, which needs to contain the ID, the primary key from the both sides as foreign key in this hash table. So after the database have those tables and columns well defined, it's time to populate the database. Here I'm talking about web scraping, of course. So in Python, the libraries involved mainly include Zenros, Beautiful Soup, and actually pandas as well. Let's go from one to the first one, which is Zenros, which is a client that helps us, create the right request that won't be blocked essentially. Because commercial sites nowadays we usually block web scraping attempts, and identify you as a bot and give you a 403 forbidden response. So after getting the right response, which is HTML like format, we use Beautiful Soup to get the information we want from all those HTML elements. Some trivial ones like the title here, which in HTML it has this specific unique class, so it's easy to find and extract it. As for others, it might be in some random table. You need to really go from the parent HTML element all the way to the child HTML element, as well as some transformation is also needed as well. For example, the date need to be transformed to the date format, because all those information originally just being text need to transform into the date, so in order to be imported into the database, as well as price. And the syntax on the SQL side to import the CSV is like the ones below. Once we have the comma separated value, the pandas. Pandas is all about we got those information pack up in the pandas data frame in order to easily export as comma separated values kind of table format, and then directly import into the database. Use a syntax like that, the SQL scripts. After the population database, so the database is pretty much complete. So you might wonder what is the usage for this database. I'd say there's a lot of usage. For example, nowadays any backend we have to read and write data from some sort of database. That's what I call API. So even though nowadays we got middlewares like SQLize for the Node or JPA, MyBetas for the Spring Boot, in the end is actually translated into the SQL language, like either data query language for reading or data manipulation language for writing the new data in the database. Here is some trivial examples, like data manipulation language using operator select to select the books, filter by region. For example, here filter all the books that belongs to Japan. So here, in order to more effectively doing the filter, we also instead of using the region ID for filtering, we want to use the actual region name of Japan, so that really involves drawing the table, both table that is involved here, there are only two because this is man-to-man relationship. And in order to write here, we use insert operator like this syntax to input the new data. Some more complicated ones, including all those many-to-many relationships or turtle relationships. For example, for many, here I gave an example of using a filtering by the genre. For example, when you wanted to try to filter for more than one genre. You want to see the books that is both manga and romantic. I'm trying to say this really involves doing the joining of the hash table, the table between them, more than one time in order to get information. As well as turtle relationship, the transaction, which both have relationship with user and the book. Sometimes you need to do the query more than once. First getting all the orders for a specific user, and then use, when you're trying to see the detail of a specific order, using the order ID to do the next filter to see all the books involved. So after showing some sample usage, it's time to wrap up, I guess. I would say for this project, it has been validated that using a centralized database to manage books as well as user or service in general, so region is feasible, but really will require lots of service logic to validate whether user is permitted to do that. In order here, for example, here in the screenshot on the right, 400 bad requests for trying to buy books from different regions. And for me personally, it's a valuable experience practicing the SQL language, no matter it's DDL, DML, or DQL, as well as some web scraping using Python and Beautiful Soup. Thank you very much.